Okay, and here we go, continuing with Mathematics Higher, paper 2 from 2014, and here's question 1. You're given a triangle OAB, with A being 3, 0 and B being 5, 2, and question A says, obtain the equation of the perpendicular bisector of AB. Well, there's A, there's B, there's the perpendicular bisector there, I've just drawn it in. It bisects AB, that means it goes through the middle and it's perpendicular to it. So let's just go on with the maths then to get this. Now, to get the equation of the perpendicular bisector, you need to get the midpoint from A to B. So you add the x coordinates, 3 add 5 is 8, divided by 2, and you half it, that gives 4. And for the y coordinates, nothing add 2 is 2, divided by 2, you get 1. So that point there, T, is the point 4, 1. And just referring back to the diagram there, don't forget that that is perpendicular to it, so we need to get the gradient of this line, and that will allow us to get the gradient of this line. So, back to the maths. The gradient from A to B is 2 take 0, y2 minus y1, over 5 take 3. So that's 2 over 2. So the gradient of A to B is 1. Therefore, the gradient of the perpendicular is minus 1, because if two lines are perpendicular, they have to multiply, the gradients have to multiply to give minus 1. So we have a gradient equal to minus 1 going through 4, 1 that we got earlier on. Y minus B is mx minus a is your start off, so y minus 1 is mx minus 4, so there we have it there, y minus 1 is m minus 1x take 4, multiply through by minus 1, and I've moved the x over to be plus x, I've moved the minus 1 over to become plus 1, and 4 plus 1 gives 5, and that's the equation of the perpendicular bisector. Just referring back to question B now. The median from A has equation y equals 2x. Find where that median meets the perpendicular bisector. Now, a median from A goes through the midpoint of the other side, and in this case it just extends, and there's the line that we got earlier on. So that's the point we're trying to get, and of course I'm giving the game away, telling you it's 1, 4. Why is it 1, 4? Because it's quite an easy simultaneous equations. There's the equation of the median they gave you, there's the perpendicular bisector. This one here you can do quite easily by just doing y take y, gives nothing. 2x take plus x, just leaves 1x, or just x. 6 take 5 is 1. So if you get x is 1, something add 1 gives 5, of course y has to be 4. So T is the point 1, 4. Okay, I'm just referring back to the question again. Calculate the angle that the line from A to T makes with the positive direction of the x-axis. Now let's just go back to the diagram. There's A to T. They want that angle there. That's the one they want. But something happens that you're just about to find out. When you get the gradient from A to T, 4 take nothing over 1 take 3, 4 take nothing is 4, 1 take 3 minus 2. You get the gradient of that line being minus 2. So there's a quick diagram, a quick sketch of A to T down here. So the gradient is minus 2, and don't forget, one of the first things you learnt at higher was that the gradient was the tan of that angle. Do a shift tan of minus 2. Now what the calculators do is they give you that one. Okay, they're programmed to give you the answer closest to 0, and minus 63.4 is closer to 0 than the one we want. This is the one we want here. So of course they both add up to 180 lying on a straight line, so it's not difficult, just take away the 63.4 and you get 116.6, and that's your answer to that.